One of the most sobering events was the Liberty Loan Parade that took place in October of 1918. This is an event that was held 1 month after the Spanish flu had already broken out near Boston, and public health officials warned the government not to hold this event.
The parade was not canceled, and roughly 11,000 people lost their lives from the Spanish flu in a couple of weeks.
Over 100 million birds were culled in China in an attempt to stall the spread of bird flu. H5N1, the virus that causes bird flu, was found in poultry in Hong Kong late last month. Worried with no vaccine and no immunity, hundreds of millions worldwide could die.
Influenza virus is a nasty virus.
We are only one step away from a pandemic situation around the world with avian flu.
Doomsday scenario is actually quite vivid. The original bird is a swan. The swan lives in China. The swan is handled by Ming Chao.
Air travel allows people to, in essence, circle the globe in less than 24 hours.
Ming Chao's cousin happens to be an engineer, and he's on a plane to the United States. In that plane, he infects 150 people.
And those people would come in contact in their home environments with hundreds of more, that you would end up having, in essence, a global health situation in a very short period of time.
Then the humans are the problem.
Over the last 100 years or so, there have been repeated instances of outbreaks.
There have been episodes where whole villages or whole clusters of humans in a valley or in a geographically restricted area have been wiped out.
The one that caused the most amount of human mortality is the 1918 variation.
At the time, it actually wiped out somewhere between 50 to 100 million people.
It killed more soldiers in the U.S. Army than all the fighting in World War I. The probability that some mutation will occur that will result in a bug that's human transmissible is, I think, fairly high.
The interdependence, the interlinkage of human cities, the high densities of population, is a critical factor in leading to rapid transmission of pandemic influenza.
So the avian flu is a concern. It's the current bad bug. People are worried about it because it's been around for a while.
Thankfully, so far, only a few hundred people are known to have been exposed to this virus, the H5N1 virus. But of those, about 50 to 60% are dead.
Birds are definitely not the enemy in this case. So the enemy is this virus that has this incredible ability to mutate.
We have the computing power, we have the technology, we have the scientific expertise. If we bring them all together under one umbrella, we can fight the bird flu virus.
The stakes in this research are pretty high. It's a life and death issue.
We have to win, and we will win.
At this point in time, the virus is smarter. Okay? Because the virus is a few steps ahead of us. It's variations that occur in the virus in its natural course of, virus makes copies of itself within our cells, and as it makes copies,
their replication system just makes a lot of errors.
It has figured out how to actually make more variations in every life cycle.
And this is actually to the advantage of the virus because it wants to mutate and escape the immune system of the host.
If your body builds a defense against one particular strain of virus, because the virus is using a low-fidelity copying mechanism, it actually creates a new copy, which is a bit different from what you have defenses for.
We know that the virus is jump species, so we need to understand how, and using computer modeling, when this kind of jump will occur.
Project Checkmate is a collaboration between IBM and the Scripps Research Institute.
The goal of our project is to predict the mutations before they actually occur, so we have the chance to create a vaccine and be prepared in the case of a pandemic.
What we're trying to do is corner the avian flu.
We're modeling it using the IBM's Blue Gene technology.
What we are looking at here behind me is the protein, the hemagglutinin protein from the virus. It's the H in H5N1. If you think of what happened just a few years ago with the Human Genome Project, biology is being transformed into an information science.
Before, we used to take and model viruses through a petri dish, a mouse, and a monkey. Now we can use it in a supercomputer and get back in minutes what used to take months.
The blue gene computer is simply the fastest computer on the planet, period.
So the Global Pandemic Initiative is a body that IBM facilitated, but it's not just IBM. It has participation from the World Health Organization, from the CDC. An example of what we are doing is STEM, is a research effort that IBM started modeling how epidemics evolve.
This has a really good model of the world. It has a model of where all the cities are, where all the people are. It has models of where all the airports are, where all the airplanes fly. It could, in the future, have models of all the bird migration pathways.
STEM is capable of simulating the entire planet.
What if scenarios? What if I actually am fast enough and I quarantine all the people? What if one escapes?
All it would take is one person on a plane from New York who's infected to infect an entire plane, and then that group of people, wherever they've landed in Chicago or LA or Miami, to spread out. This can spread incredibly rapidly.
It's going to take a lot of smarts. It's the collective smarts of the research community across immunology, virology, computational biology. Hopefully we can bring all of this together and beat the virus.
We got China, we got Japan, we got Europe, we got the United States, we have Latin America, all of them collaborating.
It is a mobilization effort on a worldwide scale that is going to be life-changing in terms of how we collaborate in the future on scientific advances.
If we do nothing about the bird flu, and we knew that this was a possibility, shame on us.